Let's open the existing drawing. Go to File Open or press Ctrl O. Go to our training folder, Civil 3D Advanced Assemblies and Subassemblies, Training Drawings, Dual Roads, and open Lanes with Superelevation Pivot at Inside Edges. Go to File Save As or press Ctrl-Shift S and specify new name. Use LaneOutsideSuperVaryingWidth shortcomings. Save it. Delete the existing lanes from the assembly. Open Tool Palettes, you can press Ctrl-3 and go to Lanes. Under the lanes, there are various lanes that you can use for your design. And let's explore Lane Outside Super Layer Varying Width. There's also Lane Inside Super Layer Varying Width. Let's explore the outside. Right-click and go to Help. If you look at this sketch, it is quite nice subassembly because you can have an inside shift width as well as outside shift width. That's great. When it comes to superelevation, it always uses outside lane superelevation. Although, if you look at this note, they say here that it always uses inside lane slope. I believe this is an error. And let's scroll to the coding diagram. And in a coding diagram, you can see that only layers S1, S2, S3, S4 do have a code. Other layers do not have a code, which means you can't calculate quantities for those layers. So if you have up to 4 layers, then this subassembly can work quite well because it has an inside and outside shift width. But if you have more than 4 layers and you want to calculate the quantities for the layers, then you can't use these subassemblies because simply there's no code for those layers. The other shortcoming is that the point codes are only assigned to the point up to P10, which is somewhere here. There's no point code for other points. Luckily, you can work around it with a marked point, but it is not ideal. Let's close this help file. And let's add it to our assembly. Go to Tool Palette, click on Lane Outside Super Layer Varying Width, and specify the location. Let's mirror it to the other side. And let's explore the properties. Select Subassembly. Under the properties, you can't specify the superelevation because it either uses outside lane slope on the right-hand side or outside lane slope on the left-hand side. So it depends if it is on the right, left, left. You can specify the crown point code if you want to add it. Then you can specify the width and default slope. And here you have a name for each layer. They call it pave here, they don't call them layer. And for each layer, you can specify the name, but that doesn't mean it is a code. Let me show you. If I go to assembly, you can see that there are codes for the shapes here, sub-base and base, and all others do not have any code. And the same applies to points. These points do have a code, but other points do not have any code. So this is the limitation. And let's run a test. Let's select this subassembly again. Go to Properties, scroll down. Under the Pave 10, there is a name. And let's change the name to Layer 10. If I do that, it has no impact on a code. So that name is not used for codes at all, which means you can't calculate the quantities for those layers. Let's test some other settings. Go to Properties. And here there's an option that for the second layer, I can specify the width specification. I can either match the previous layers or there's some other options. Let's use the inside offset, outside offset. And then I specify the offset 0.2, 0.2. I will do the same for the third layer, 0.2, 0.2, but I must specify that I want to use an inside offset and outside offset. And let's set the 0 depth for all other layers. So let's say we want only 3 layers to be used. So for the layer 4 depth, let's use 0. Layer 5 depth 0, 6, 0, 7, 0, 8, 0, 0, 0. And let's look at the assembly. I zoom closer to the point codes and you can see that although the layer depth is equal to 0, it still creates all the links for those layers, or even the shape, which is not right. This is not properly developed subassembly. If the layer is equal to 0, then the layer should not be created at all. There shouldn't be those links created with this subassembly. But unfortunately, this is the way it is. Although it might not harm your quantities or anything, it can harm the performance because let's say 20 links are created in a corridor for no reason on top of each other. And let's look at the shift width, and that seems good. I didn't specify it probably for the third layer. Let's rebuild the corridor and let's see how it looks in the cross sections. Let's go there, and this is the result. It looks good. So this subassembly is useful if you don't have more than 4 layers. If you do have more than 4 layers, then I wouldn't suggest using it. And what I wanted to show you with this exercise is that some subassemblies do not have all the required properties that you would expect from that specific subassembly. So keep that in mind, that you might sometimes hit the wall. And in those cases, if you don't find a solution with the default subassemblies, the only option is to use Subassembly Composer or to develop subassembly programmatically.